Okay, just checking quickly to see if my volume is working. I'm assuming it is. Um, but at the same time, if you can't hear me, let me know. We're going to get going soon. Just please let's ask questions if you have any. Sweet. All right. So after going, we're going to do a little in-class exercise. This got a lot of the lecture today is just going to be in-class exercises because I want to make sure you're prepared for when we hit the next couple of like the homeworks, which is the DearData homework set, and also the project 3. But I can also answer any questions you have about project 2 as well. I'm going to do that in about 2 minutes when everyone presumably trickles on in.
Hi, I have a question.
Sure.
So, what visualize statement can I use to make my y-axis to be descending? Because like my
Ooh.
y-axis now is like the numbers are ascending.
Yeah, they flip it around, don't they? Just for
Yeah,
fun.
yeah.
Ugh. You might think, wow, this is terribly organized. Yeah, that's the entire field. Half the time it's down, other half the time it's up. It's a thing. Um, I don't know if there's. I've never tried. Never thought about that. I'd have to look into that for you. Um, and you're already on Vega Lite because that was what the lab is supposed to be this Thursday. I'm trying to get you.
Yes, I'm just want to try that.
That's fantastic. You're trying. That I have no problem with that. Um, it's just because your number system is inverted, right? I'd have to look into that a bit for you because I don't know off the top of my head. Vega Lite is there's unfortunately the whole field got very fragmented. So for a while, D3 was the be all and end all. Everyone's talking about this thing. And then people started going, well, we don't actually need all of that. We could just use Tableau or all these other systems. And so they started making easier to use systems. And so you have things like Altair and Vega Lite, Vega, things where they're trying for a simpler solution, but there's so many people in the space. There's no one unified, everyone's using this thing that it's actually really hard to find great documentation on any. They're trying their best, of course, but it's even something like I have it available. Let's see if I can plop it up here for you guys. Or you're not seeing anything yet, but you'll see it soon. And we'll get going in a second. I need to. Am I recording already? I'm recording. Great. This is me unable to open project folder. Let's see here. Oh, I have two started because I renamed it. Okay, that's fine. So here is what I was trying to do. The lab. Great. Very effective, don't you think? And then I'll do the following. Here is, and honest to God, this is me hitting this bug today and going, what is wrong with this thing? I've looked at all the examples I can find online. There's all this kind of stuff I'm trying to do. And for the life of me, I cannot figure out. There you go. This is me dumping my entire JSON file into my JavaScript file. Like essentially just taking it, plopping it straight into my file. What I want to be able to do is read in a text file, which I do in my homework for solution code. That works just fine. And I looked at it and I'm looking at my JSON file and it looks just fine. By the way, one of the really nice things I found out about this, even if I get rid of that, let's just get it back to its original starting state. But even when so this is almost exactly identical to what I have in the JSON file here, other than the word values and the colon here. It's being read in as data, and yet for the life of me, I cannot figure out why it's not working. Yet, despite the fact, if I go to, let's say, my solution file for, here's my JSON file for Vega Lite Homework 4, and here's my JSON file, and it looks like this. There's really no difference between what's, there's just, I'm missing like a character or something like that along the way. It's extremely frustrating. It's all very frustrating. And the only advice I can really give is, it's somewhat par for the course and getting used to how to look up documentation, how to find out how to do something. It's the greatest experience in the world once you finally get it working and off the ground. But oh my God, you thought C++ was frustrating. At least that's documented. Uh, or C, I guess you guys haven't done 2400 yet. But I fully admit it can be extremely frustrating. And so the only answer is just do a little bit at a time and see if it can get it to work and try different things. Like, for example, I had this thing, it wasn't working. So I plopped plopped it straight in my JavaScript file, saw if it worked, and figured it out from that. But to answer your question, I don't know how to reverse the axes yet, but I'm assuming it's going to be in this part here. The y-axis, I have this. Maybe there's a flag for inverting the axes. I have a sneaky feeling that it's in there somewhere, just in the description. You take in the text and we will flip the axis or something like that. Because what Vega Light is, in case people are not to get ahead of ourselves here, what Vega Light's actually doing is we're describing what we want to see. We're going to have bars as our various marks, and for each of the bars, we have an X coordinate, a Y coordinate, which we're using certain fields with certain data types. So I have nominal data. I thought it was going to be categorical. It's nominal. That's why I had a bug earlier. So I have nominal data, different categories of data, and the field I'm using is the ward, and that's what I'm seeing here. On the y-axis, I'm saying I'm going to be showing the number of cases per 100,000. That's quantitative data. And then you just let Vega Light figure it out for you. Now, I can also say what the tooltip might look like. I can say what this looks like, what that looks like. I can tell a bunch of, I can say what kind of colors I should be using. Fine. I can describe the way I want my data to look, but I'm not dealing with the data itself. Vega Light does it. So it's a descriptive language. When I get these numbers, look in this field for this value, show it for me, versus me controlling everything along the way. If you're a control freak, like I'm not really a control freak, but every once in a while I am. That can be a little frustrating, but that's the whole point of this is that you're not getting in the way of, or you're not getting your hands dirty with the data. You're just describing what it looks like. Here's the data. Here's how to represent things, or how I want it to show. Go do it. That's what Vega Light is. It takes away a lot of that weird, quirky stuff. Okay, so here's what we're going to be doing right now. Let me plop open my PowerPoint again, just because I found this slide and went, hey, yeah, I should show it, just because the whole Super Bowl on Sunday. Yes, there was a Super Bowl on Sunday, in case anyone was actually paying attention at all. We're in Canada. It's not a given that people would watch Super Bowl. We have adopted the Super Bowl in our household simply to eat the food. I don't think my wife actually watches the game. I don't think my kids watch the game. My son went downstairs and played the entire time while we were watching the game, and I had to explain how the rules of the game actually worked about on the third quarter. Like, it was, yeah, what a first down is. Like, it was, we're not football people, but we like eating crap. We like eating really terrible for you food, and we had a lot of it. Okay, so here we go. Here's a visualization, and this is what I wanted to point out today. We're talking about color and how to get these pop-out effects. In fact, so we looked at what are called pop-out effects. Effectively, what our base level of perception is, the very, very, very basic stuff that we end up seeing. That's the stuff that stands out the most. So a new color, we see it right away. Movement, we see it right away. Something that's abnormal in this set of numbers, we see right away. But if you put too much of that stuff in there, you get nothing. So you have to choose what you're doing. You can't pack in too much stuff, otherwise you get nothing as a result. So you have to sort of figure out exactly what your task is, which is what P2 was, and which is where, by the way, I was very impressed with P2, even if it doesn't seem like I was impressed with your P2 answers. I was very impressed with everyone's P2 answers. There were things that everyone always had something to work on every single time. Even if I gave what you thought was a low mark, it's because I can't give everyone an A. And there's always room for improvement, right? So if I don't have the data set, or if I don't think you have the exact task in your mind, or you haven't gotten to the exact specifics yet, okay, things to work on. But generally, it was really well done. It was very methodically done. And I've seen a lot of terrible, P2 kind of projects in other courses. in the past where people just sort of said, yeah, we did stuff. We did an interview. It was fun. And you're like, no, right? You guys did a really good job with that. So I was impressed. Um, so keep up the good work. I mean, I'm going to keep on asking for more and more, but you can deliver. I know you can. So that's sort of the point. So if you don't know your task, how are you going to get a pop-out effect? If you do not know your task, how are you going to focus their attention on particular things you need to focus people's attentions on? That's the point. I have a very limited amount of bandwidth. People are really good at seeing things, but are particularly great at seeing things if you know exactly what you're trying to show them, right? If the thing that they're looking for is this, I know ways of helping visual perception so that we're better than a computer. Okay. And it can make actionable insights. Great. But if I don't know what I'm doing, I'm just throwing data at people. It just, it's a wash. Like you're not going to see anything. Okay. So part of the thing we're looking at is getting it right in black and white. We're going to look at black and white to a certain extent today, and then we're going to look at color if we have time. The reason it's get it right in black and white is because you get things like this, right? When we get to, I think it's part of the color lecture though, we'll be looking at your two visual processing systems. Now, this is not something I learned as an undergrad. I actually learned that watching one of my friend's dissertations actually, and went, oh, everything makes sense now. We don't see color the way that we see black and white. In fact, we have two completely separate visual processing systems, and we're blissfully unaware of it. They work together, sort of, but it means that what you represent with color is radically different than what you represent with darkness and lightness. So you need to make sure to represent it in darkness and lightness with a black and white, if you go to black and white. In fact, this is what you may have discovered when you got my feedback. I have a black and white tablet here. So your visualizations, yes, should be color. But I'm seeing it all. I'm just letting you know, I'm going to be seeing your visualizations and everything you're doing in black and white anyways. So you might as well get it right in black and white. Sure, have color. I'll refer to it as well. But if it's in black and white and I don't see the differences of the bars or I don't see the dots, there's something wrong. Okay. We'll also see why. So we talked about light. It goes in, it hits the back of our eye, it reflects up, it goes to photosensitive nerve cells called rods and cones. They activate, and then we have a whole bunch of extra processing just behind it with bipolar cells. So that depending on if two neurons fire, one inhibits the one nearby, and you can get these very basic pattern matching. From there, the neurons pop out the back here, shoot down your optic nerve to the back of your head, boom. And at the back of your head, you do all your visual processing. And it goes up this way for the most part, higher and higher levels of visual processing up the back of your head, essentially. Okay. Important points to bring up. We have lightness and brightness. It's just nice to say luminance. Luminance being the amount of visible light that you get hit your eye. Brightness is how bright a reflected light is. Lightness is how light intensity is. So something that is a white piece of paper is bright in the fact that if white light hits it, a lot of the light gets reflected. Even better would be like a mirror is very bright, right? Especially when light hits it. Lightness is like the brightness of the lightness. Oh God, terms. Something like a light bulb, right? It emits light versus just reflecting it. But luminance covers both those, whether it's on paper or whether it's on a screen. It doesn't matter. We can call it luminance. Weird thing about luminance and lightness and brightness and all these kinds of things is we adapt to our world. Remember, our eyes are moving constantly around and we're piecing together and making our world as we look. Meaning, I get low. It's all about the local differences, not global. And so this O here is actually darker than this black text over here in terms of actual measurements. This is the center of the O right here. This is the S over here. That's insane, right? But that's how we see our world. It's how you can look outside on a bright day, see inside your house as well, and you actually see everything correctly. because it's not relative to some global amount. The light outside is different than the light inside a darker room, yet I can see and compare those differences. So we have things like this, where if I have a gradient, it looks weird. This looks like it's light, that looks like a really dark gray, that looks like a really light gray, and yet it's actually just one gray bar. It's all relative. Same here. Okay? If I put them together, they're the same gray bar, if you didn't believe me. And in fact, if I animate them together, same gray bar. No magic. All I did was notice, by the way, notice that there's a clicking. As soon as there was no bar in between them, as soon as they stopped, they touched each other, suddenly it looked like one unit. Because that's how we see. We see the boundaries of things. And so when they were near each other, even if you were realizing they were the same color at that point in time, you still saw that little line in between made it look like two separate blocks. And as soon as you touch them, boom, it's one block. You're designed to do this. Similarly, that A and the B, oh wait, they're the same damn color. And I still can't, even after knowing this little trick, I still can't see it. You naturally fill in that gap. You naturally will see this B because of the shadow. You see this B as being lighter than this A. So what effectively we have here is we don't have any edges whatsoever. We're going to see this in a second without lightness differences. So I don't see the outline of things without changes in lightness, not color, lightness. And that's a weird thing that we're going to look at. That's that two processing system thing that we have. We have no shading without lightness variance. And so that's one of the reasons we like getting rid of 3D, is because if I have 3D, I need shading to show shapes and stuff. And because it's three-dimensional. And yet lightness is how we tell edges. Really, you can get a lot of convolution there as well. We have higher spatial sensitivity than color for them. The luminance, the brightness, has a higher spatial sensitivity than the lightness channels. So in terms of yellow versus green, we don't see that very well. In terms of bright versus dark, we see that really well in three-dimensional space. We know exactly where it is located in space. Contrast defines legibility, attention, and layering. So how I can see, one thing stacked on top of the other one, how I can read text. In fact, you reading this slide, notice what color my background is. Notice what color my text is. How many times have you seen a PowerPoint presentation with the background color? Maybe I should actually do this just to show people the problem. If I change the background color, even if it's a completely different color, as long as it's dark, I can't read it, or I have a real hard time reading it. Dark text on dark background or light text on a light background, next to impossible to read. You can see the text, you just can't read it. The reason is because you to see the outlines of those shapes. The way you read text is based on lightness to darkness, nothing to do with color. So controlling the luminance, controlling how bright something looks, is a primary design rule. You need to be complete control of that thing. And on purpose to throw you off, or because they didn't know their ass from a hole in the ground? I have a slide with that just to be like, oh my God, this is terrible. Oh my God. Oh no, 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 no. Oh no, no, no. I don't know how many other psych courses you have with that are doing that, but no. Anyone doing any kind of perceptions, like, no. Yeah, you should not be doing that. I don't think I want you to tell off your prof for that, but at the same time, okay. Because this is one of those things I learned. Why are when you're talking about fonts, why is a serif font bad? It's not that bad, but it's bad. Why? Because I see lightness to darkness, and all this the serif font is actually just convoluting things. And they don't have the bleed over effect that I do with print media. So why am I having a serif font? Why is it that Apple designs things the way they do? I've learned over time. I didn't actually get this formally trained when I was going to grad school. It's one of those things I learned over time. So, by the way, I love Thank you, by the way, for pointing that out. Although that scares me. I love the little illusions. Oh, here's a, we already talked about this as an illusion, right? The lie factors that we looked at, but Shepard's table illusion. What I end up getting is all of our visual system is based on perspective, and we will our eyes just force certain things based off of the shapes we see, predominantly in the luminance channel. So that's hard edge on the table, for example. But I would like you guys, and we're gonna get a lot of the same ones over and over again. But I find this a fun little exercise. We're going to do it fairly quickly and just throw it into Drive 7. Find your favorite optical illusion. Everyone has one, or most people have one. So things that like colorblind testing, uh, things like Escher's reality art piece, whatever you want. There's a bunch of them. I have a bunch of them in the color lecture as well. What is your favorite optical illusion? And let's see if we can find a couple of them that might be interesting in terms of brightness, darkness. Maybe we can look foreshadowing into color. And even if you have some color issues, for example, like if you're red green colorblind, there are optical illusions just to help people that are red green colorblind or help people that have some kind of visual issues. Because why not, right? And so this, for example, and I'm blissfully unaware what the heck this is. I think it might say color blindness sucks. Or color sight is overrated. I don't know what the heck this says. There's some message here. I have no idea what the message is. The only people that can see this message are people with, I think it is, I'm always blank on the Latin word, red, they're missing red cones for their visual processing system. I think you have to be red green colorblind in order to see this optical illusion. No clue what it says. So if you want, you can try things that only you can see that other people can't. But I would like you to try for just in lecture 7, just 5 minutes, find your favorite optical illusion, throw the image up there. We can look at a couple of them. Okay, I'm going to go and pull up. So I'll leave this up there, and I'm going to look for what kind of things we may have. I already have one from Kara. Oh my God, you're hurting me. Oh, that's beautiful. That is a beautiful, horrible. Oh, duh, duh. Okay, I'm gonna have to back out for that one. I'll be pulling up a bunch of these. If any of you are susceptible to, some kind of horrible pain when you look at optical illusions, let me know. The elite Zoom background. So elite, it makes everyone else vomit. Ah, there's an entire episode of How I Met Your Mother on this one. I love it. Nice. I use this as an example for perceptual priming. I'm not sure if I have that for this class. I do in my HCI class when I had an HCI class. The rabbit or duck. Nice. You might have to put your name on it to make sure that we know who submitted it. But so the rabbit or duck. Some of you see a rabbit. Some of you see a duck. I automatically see a duck, unless I turn my head to the side. But there's an entire episode of How I Met Your Mother about rabbit or duck and which is better. Good times. Have a watch of it if you have a chance. But if I told you if I showed you a picture of a rabbit beforehand and then show you that picture, you are more statistically more likely to see a rabbit than seeing a duck compared to just randomly showing that picture, which leads us to perceptual priming. If I say, look for this shape, what do you see? We'll actually see an example of that when we talk about the gorilla example and the basketball example. Uh, and I think there's a couple, then there's one more that, oh yeah, the stormtrooper example that we're going to be seeing. Perceptual priming. Very nice. This is what Kara showed. Oh my God. Oh, yeah. I have to close my eyes on this one. Why is it giving this throbbing? You're going to hallucinate with this thing. Why? Because you see those edges, but they're mixing up color, brightness, and this weird shape that you have. And since you can't see everything at all, when you look smack dab in the center, everything else, your visual processing field, your visual processing ability as you go out, lower is less acute. And so what you end up getting is this weird wavering effect as you move your eye around. The image is wavering and it really hurts. So thank you for causing pain to all of us, Kara. What else you got here? Wow. But that is cool. Notice what you get here. You're getting shape without wanting to. You're getting a shape because they're changing where the shadow is located on each of the circles, which then tells you that gives you topography without you realizing it. And so you should see some kind of shape or some kind of texture to the background as a result of it without you even trying. Little tricks for your eyes. Love them. Oh, nice. And I think my doctoral supervisor did work on this actual problem. And also, you can watch Inception as well. Good times for that, right? It's because of how your eye works, and because you only see local areas, you see an infinite staircase, which is shouldn't work, but it does. There's a break somewhere in there, right? Do we have another optional? Oh, there's a dock. It's going to be nice. And the old lady and the young woman. What is it called? There's a proper name for it. I only see the young lady, but that just might be me. Uh, oh, there's the old woman. Got it. Now, the ability, there's even a proper term for it, which I'm blanking on the name for, proper term for being able to see both options and you shift between the two of them. But that is different, can be very difficult to do. Some people will naturally see one or the other, and then you have to sort of work to see the other version of this. So, in case you're wondering, woman's facing away from you. If it's a young lady, feather in her hair, shawl in the background, versus old lady, it's a headscarf. There's the nose there, there's the chin, there's the mouth, there's the eyes. And a variant on Escher's reality. It's a rendered version of reality, I'm assuming. And our favorite Herman. But notice, by the way, how because you're looking at one place, that's why it works. Because if you could actually see the entire scene all at once, you would know it would be gibberish. Oh, what is that one? Whose is this? And what is, are we, that's freaking me out. Why is it freaking me out so much? It's person upside down. It's beautiful. It's a woman, a princess upside down, or an ugly guy. Oh, that's crazy pants. Love it. I've just never seen that one. And I have one of those. I have the snakes later on. Just to freak you out. Oh, nice. We'll look at this one as well as an optical illusion. Very nice. And more like making me want to vomit. Okay, nice. But see, it just the oh, mm, the same technique is being used over and over and over again. It's I'm looking at one place where I have high visual acuity, and outside of that area, I don't. And as a result, I get this weird wavering effect, or I get optical illusions because I'm only looking at one part and then I look over there and it's contradictory information. The fact that the length of these arrows, that's higher visual processing, right? That the length of these arrows, all of these arrows, the lengths of all these lines are exactly the same, and yet you cannot help but see this as, well, Oh, because they changed this arrow ahead. You cannot not see it. But now when you switch to color, although I would argue it's not the red, it's the fact it's a slightly lighter shade is why you're seeing that. You recognize them as three different colors, but the reason that you can see that they're all, no, actually you put a reference line, that they put a reference line here as well. So that's why you know for sure that actually works. But you have to fight against your visual processing system otherwise. But we have other ones. Oh, Devil's Fork. But the fact you put this in, oh, actually that works even better as a result. Nice. Normally they don't have the green and the blue circles in there. Oh, nice. I'm assuming Owlman and Batman, but Owlman's costume doesn't look like that. So, uh, or is this Owlman from? Oh, this Watchman, Owlman, right? Oh, Penguin. Oh, Penguin. Nice. Could have been also Owlman from the Watchmen, which is actually an homage to the Blue Beetle, in case you didn't know from the original what the original was. Oh, nice. That's beautiful. Oh, well, okay. That's moving way too much for me. I love these. I want to see all of them, but oh my God. Where did you find that? That is crazy pants. Sorry, I can't help but see this ball circling around it. That's really wild. That's a brand new thing. I love it. Okay, I can't still show all of them, but that's really nice, guys. I'm very impressed. Those are some brand new things for me, by the way. Okay, so let's go back to see what we had. That was the end of that lecture, right? Okay. I wanted to make sure we spend a lot of time. I'm still impressed by all those things. I want to make sure we spend a lot of time going over what the next couple assignments are. So I'm actually ahead of myself for when it comes to color. I think next lecture is supposed to be the full blown dissection of color. So I want to go over some of the things we're going to continue looking at visual perception for a little bit. We're going to look at cognition soon after that, how we think, how we process not only what we see, but how we act on certain things. How can we accommodate for color blindness? That's what we're going to be doing very, very soon. Uh, how to use the color channel versus luminance as a channel. But first, we need to look at project 3 and homework. I think it might be 5. I think it's 5. The DearData homework. The DearData homework is interesting in I love it. I had an immense amount of pushback, like a really ridiculous amount of pushback when I taught this to computer scientists. So I was teaching, well, they're data scientists. They're loving coding. They're just deep diving into code. And then I give them this thing and they hated it. Why are we doing this? Why are we getting out pens and paper? And I may not have explained myself very well. And then I sent it to you, the previous iteration of this class last winter. And a number of the students loved it because you can't crash paper, first of all, number one. And number two, the whole point of it is creativity. It's not a matter of how do you code something. It's very much in the artistic bend of things. And that's what I love about it. And people got it. So I don't think I have to plug it as much as I did in the past when I was teaching it to computer scientists. But here's the idea. Uh, when we're talking about using a computer for, Tableau, using Tableau, for example, or something like along those lines, we're so used to having these incredibly large data sets and these great tools to let us do the job that we're not even thinking about what we're doing. We just play with a bunch of stuff. And what we need to be acutely aware of is the design process. That it's not just pushing pixels. You have a purpose, you have a very tight series of constraints, and you're trying to sort of maximize what you're conveying in an evocative way. So the design process, one of the great things about design is it's based on constraints. the more constraints you have, the more creative you actually have to be to work around those constraints, those limitations. So this is where DearData Pen Pals comes in. The idea originally was there was two visualization experts from two different continents, one from the UK, one from America, and they decided to try for a year. For a year, every single week, they took down data for what they were doing in their day-to-day lives, and they made a unique visualization per day, oh no, sorry, per week for a year, and literally sent these postcards to the other person every single week as in a thought experiment, which is weird because we're not used to doing this kind of like, there's no publication on this thing. It's a fantastic exercise. So we have adopted it for this class. We're only doing it twice. We're still doing it twice. So here's the idea. This is one of them. This is or an example of it. I have other examples. This is Cody Dunn's from Northeastern University's visualization, and this is the kind of postcard you'd get. It's the size of a postcard, not bigger. It is not a piece of paper. It is not a poster board or anything like that. It is an index card. This kind of thing. An index card's worth of information. That's it. It has to be novel. So it's not a bar chart. It's not a line graph. It's not pie chart. It is something brand spanking new, whatever you want it to be. It's about data that you see in your daily life, and we'll show you what the prompts are. And it has to be done by hand on a piece of paper, not scanned in the computer, not done in Photoshop and then printed off onto a piece of paper, done with a pen and paper or multiple pens, colored markers, a ruler. Break out the craft supplies. It's going to feel like kindergarten again, but that's the point. If I remove all of our little crutches that we all have, how do you go about it? We're not worrying about your artistic skills. Like, this is the smiley face. Look at this thing, right? He's not an artist. This is a computer scientist doing this, like a hardcore computer scientist doing this. So in case you're wondering, what the hell is it? It doesn't have to be self-explanatory on the surface. The other side of the card is the instructions. I have a from, who it's from, and a to. Now, what we're doing, because I want to make sure it works, they used to send it to their grad students, and then the grad students would write back and like, no. We're going to give you all a unique identifier. So we'll use the last four digits of your student number. We'll give you a unique identifier, and we'll give you an identifier for who you're writing to. So your ID, who you're writing to. And so you're just going to write a to, it's from 123 to person 456. So fairly simple in that respect. And last year, before this whole plague thing went down, we literally had you make postcards, and I passed them out to everybody. You're supposed to be completely anonymous. You don't know who's writing to you. You don't know that they don't know who's writing to them. That's the point. It's completely anonymous, so you don't bias each other's work. And on this side, so you have to and for the to and the from, and you're writing instructions for how to read this information. So whether the book is intact, if but afraid, whether the book was mauled, whether it was devoured, what the color the book was, or the books were arranged in rows of two books of the same colors and adjacent, where the book was selected from the floor, the shelf, whether it was repeated multiple times, whether it was selected from Dad's face. This is Cody reading to his infant daughter on a particular week, and each of those books represents a single book that was drawn and the book that was being read. He read a lot of books, it seems. Book was selected by the baby, the dad, or violent initialization of reading. So as in started screaming and wanted to be read a book, I presume. This is what it looks like. Whether the book was devoured, was read multiple times. I'm assuming devoured meaning the baby was chewing on the book. Whether it was from the shelf, whether read multiple times, whether it was only partially read, that sort of thing. Okay, that's just one example. There's a ton of these examples. I didn't get it in time for this lecture. I have an entire packet of them from the class last term, for example, that I can show you. although this looks phallic, it's not meant to be phallic. I've had to just sort of stifle a giggle because I'm a child. But my son did video games that he saw in his house. Now, this is for his elementary school class. They were just like, count things in life and make a graph or bar chart. And so he did this, which is the color of the cases. This is so for the Xbox, for the Wii U, because we had a Wii U at the time, only a Wii U at the time, not a Switch. And so red cases, blue cases, black cases, and green cases for our two main gaming systems that he was using. And so I took that same data set because I wanted to do something myself. And here are my initial sketches, me doodling stuff out on a piece of paper. But what I could try and do, this is just, and I expect this, you expect to doodle a ton. And then you try a draft. And oh, that didn't work. Try another draft. Oh, that didn't work. Until you finally get something like this. So this is by no means perfect, but this is the same kind of visualization that my son was doing here. And I'm using what I'm calling a pencil chart. So the idea is 4 games that you can play multiple games from, you get this span out pencil graph from it, which is the number of characters you have for this thing. This is all Disney Infinity games. We have a big bundle that we got from a garage sale, right? The game. So this is Lone Ranger. This is Monsters University. This is Cars. This is just Disney Infinity in general, The Incredibles, that sort of thing. And how many different characters there are. And plus, on top of that, here's episode 2. Notice there's a lightsaber, right? So here are the blue games that we have for the Xbox and the Wii U and the Xbox, because they're cross-compatible. Here are the various games we have. Here are the various controllers that we have, sorry. This is all my Xbox games, for example. Can anyone guess what this game right here is, the all green one is? Or can anyone guess what that's supposed to represent? I'll wait for that. So, by the way, Disney Infinity Games. Great guess. Great guess. No, I wish. That would be much better than what it actually is, but that is a perfect kind of guess here. No, I bought it at a garage sale, didn't have the game inside of it. So we have a case downstairs with no game in it. Yeah. That's that's what that one is, right? But the little playfulness in your thing to make people go like, what the hell is what? Kind of fun. Or at least I'm hoping it's fun. This would be 2 discs in a box, for example. And maybe you guys can guess what that game is. Maybe you can't, but maybe you can. Maybe not. No, it's too old of a game. This would be Mass Effect. 2 of the Mass Effect games. I should have, I'm not sure. Mass Effect 1 only has 1 disc. I'm surprised. Anyways, so that would be the Mass Effect, parts of the Mass Effect trilogy. How many game controllers we have? This kind of thing that I was doing here, but we're playing. The big thing is you're not drawing the first thing that comes to mind. You're doodling a bunch of stuff out. You're playing with it. Then you do a bunch of rough drawings, and then and only then do you get out the index card, get out a ruler, get out your pens and your pencils and stuff like that, and manually draw this thing out to give you something like this, and that's what you pass in. That's what you do for the DearData assignment. Number 1. Here are your prompts. I'm going to make sure I do a separate post on this to make sure that everyone has this. So what, when, and where are you reading? That's especially useful for reading week. I want to make sure that so during reading week would be a perfect time to be collecting this data. You're not going anywhere, but you're at home. I'm sure you have nothing to do. You're not catching up on work at all. No. You're just resting, lounging around the house. But these are the kinds of things you could be collecting. You have to collect it for a week. So don't just, and ask questions, by the way, just in case you're concerned. Can I ask, download cap was okay. So where are we reading? Where do you say thank you to people we meet? What animals do you see in an urban and not so urban environments? a lot of people do that one. It's kind of getting kind of a little bit boring, but it's still fun. What makes you feel envy and why? Right. This is not just make up whatever you want. It's not art. It is you're collecting data, you're visualizing it. Now, it'd still be artistic, but it has a purpose. I had somebody give me like an art piece, and I'm like, no, that's missing the mark. How often do we complain and rant about, and what do we rant about, and how many of our complaints are unnecessary? Right? It's about reflection on your daily life, and we're just using these prompts simply so that everyone's using the same has the same level of options. It's not an apples to oranges comparison. If there's a prompt that you want to try, let me know. But it has to be something that you have to monitor throughout the day, not something like somebody asked, my phone apps, which phone apps I used. Yeah, but at the end of the day, you could just look at your phone, pull off the data, and you're done, right? You're not collecting it throughout the day. And so that's sort of, you don't have to be obsessive about this, but you're supposed to be sort of attenuating or paying attention to it throughout the day. Every day, when you start reading something, just put a little mark down, right? Every time you see an animal in your urban environment, if that's what you're going to be working on, what compliments you received and appreciated given to others, for example, uh, positive thoughts of the week, and where were they directed towards, things like that. When do I make? You could do what food I made for myself, whatever works for like. We can add prompts if we want to, but everyone needs the same set of prompts that they can play with. Now, you don't get to do your own. If you get that prompt, everyone gets that prompt. Okay, so based on this, you collect data throughout the week. Then you visualize that data on a postcard that you draw out. You put the instructions of how to read your visualization on the back of the postcard. If you do not need instructions, it means you did it wrong. If I understand exactly what you were doing and exactly how to read this thing because it's in a bar chart or a pie chart, you did it wrong. It has to be something unique and novel. Now, it should be somewhat obvious when you're looking at this, but still, it should be novel enough that there should be some explanation. So far, so good. And then you're going to once you get that card, you're going to take a photo of it or scan it or whatever you need to do, high quality image of it, and you're going to submit that. So you can keep the actual paper card yourself. Don't throw it out because it's nice to have around, and also, nice little memento. Maybe laminate it. No, I mean, just you want to be able to have it just in case someone goes, hey, I don't think you did it, or hey, I think you did it in Photoshop. Okay, so you have the card. Once you have the card, you take a photo of it, you submit that photo, both sides of the photo, plus your notes to see you learn. The instructions are online. Then the other person is going to find out who they're reviewing. Uh, so we'll get to P3 in a second. So you'll see who you're reviewing. And then the next homework is you reviewing the person's visualization. You don't know who you're reviewing, but you're reviewing them. We can then send that feedback back to that person. Sometimes we don't, depending on how rough people are, and how quality or work is. In cases where we're afraid of hurting people's feelings, we won't necessarily send the feedback back, but we're trying to send the feedback back so that when we do it again, you could take that feedback and improve your next time you do this with the same kind of prompts. You can do a completely different visualization, but the same kind of prompts. It's not meant to be a crazy time sink, but it's meant to be sort of paying attention to your life, making a visualization without the crutches of technology to help you. That's the point. Okay. Any questions about that so far? Questions will pop up soon enough, but nothing so far. Okay. Is digital drawing allowed, like using, I don't want digital drawing. The reason is I don't want that set. The only digital drawing would be something like this is pushing it. Why? Because it's like a pad of paper, but I'm using a pen, and it's direct my thoughts into my hand onto the sheet, right? I don't want that separation. Now, I've seen one person in my life. I've seen one person so far a lot of people said, I use Photoshop just as well as I use a pen. And I go, really? And they go, yeah, yeah, yeah. And every time, except for one person, and that's because they didn't use a pen enough, right? So I don't want something that looks like it's done professionally. I want something that looks like that you had to do it by hand. And the real kicker is if you make a mistake, well, that's a big deal, right? It's not meant to be just some crappy doodle, which some people give me. Don't want it. We tear them a new one when that happens. It's but if you put that line in there, you can't undo it, and so you have to be very very careful about every single thing that you do, and that's the point of it. And if you use Procreate or something like that, now suddenly you can just undo. So it's sort of a workaround, and so it defeats the purpose. Great question. Uh, we're going to do a little in-class exercise in a second. Uh, so we're going to be talking about P3. P3 is your sketches for your visualization. You should have, and if you don't, please talk to me or at least get it done. You should have your data and you should have your task. If it's still up in the air, great. I would love to talk to you guys about this, but this shouldn't be like, I don't know what I'm doing right now. You have data, you have a task. Hopefully the data is clean. And if it's not, you got to clean it before you get to this next part, or you need to clean it very, very, very soon. So part 3 or project 3 is, and we could have done data cleaning, I suppose, but project 3 is you doing your sketches. Your sketches. It's not your final draft. It is, I want you guys, this ideation phase is a fancy pants term we'd like to use. It's play with the idea to see what the best design for it is. So, I like pointing this out. So I like saying you will get it wrong because everyone gets it wrong, regardless of your experience, regardless how many years you've been doing it. Something is wrong. The kicker is it's how do I want to say this? If you're playing a sport, you at least a fast moving sport, not curling, I suppose. But if you're playing a fast moving sport like soccer, say, no matter how good, if you're in shape or not, you should be sweating by the end. Even if you're in the World Cup, you should be sweating at the end. Why? Because as you get better and better and better at it, you just push yourself more and more and more, right? Same thing here. Your designs are not going to be ever perfect. They're going to be closer to being right the first time as you get more experience, but you're still expecting your standards go up higher as you get better. So no matter what, something's wrong. It's never perfect. And so I would like you guys to walk in with that thought at least, right? When you pass me your designs, I'm not going to say, perfect, I have no notes, right? There's always something to be fixed. There's always something to be improved on. That doesn't mean you didn't do a great job. It just means there's always something. There's always something wrong with my lectures that I can improve. Just part of the process. If you come at it as a sort of a all or none approach to things, if you assume, hey, if I do this, it'll be perfect, it's a, it's not a very growth oriented attitude. So I'd like to point out, you're going to get it wrong. That's fine. I'm expecting it. I'm expecting that you put in the work and it looks like you put in the work and I have minor changes versus like you didn't think about this at all. It's a flaming pile of garbage. No, I don't want that stage, but there's always something wrong. Okay. I'm not going to show the video, but I love pointing out things like this in case you don't believe me. Um, the idea of how you generate ideas, there's entire giant reams of research on this sort of idea for your group. I watched a TED talk recently about this, and it was really kind of interesting, and it's something I keep on reminding myself of. The key for ideation is that there are no wrong ideas. There's no bad ideas. Throw crap at the wall. Just generate afterwards. So don't get in your own way, right? When you're writing an essay, just come up with ideas. Don't worry if they're any good. Don't worry if they make sense. Don't worry if they're stupid. That's fine. the stupider, I like actually intentionally putting in the stupidest possible ideas I can into the mix, just to make sure so to sort of get in the way of the embarrassment factor, right? So that you say, I'm going to say something ridiculously stupid to my partners, warn them in advance, sure, great, so that they know I'm going to try something ridiculously stupid. They have no problem, we can get rid of it later. But some real just bonkers ideas, fantastic. Because some of the best ideas come from the bonkers ideas that then suddenly that people go, oh, but we could do this, and we're good. So the party vote system I keep on referring to, it's an old system, but it comes from, I want something bonkers. I had a problem with music at a house party. How can I show that information, music at a house party? And the whole thing just flows from there. Is not what the original, dummy idea was, but the dummy idea led to something interesting. So they're talking about how to make a better shopping cart, and they're just throwing stuff at the wall, seeing what sticks. They're not trying to make polish. They're not trying to make it look like a real shopping cart. They figure out who their users are, what their task is, and they just throw out ridiculous ideas, throw things together, and eventually then they whittle it down later. Ideas are cheap. You can throw them away. So you throw out too many ideas and then we whittle them down. That's the premise. Okay. So this is literally what people will do. We're not doing paper prototyping, but I love paper prototyping. If you get to do an HCI class, you probably will do paper prototyping. Some people say, oh, why are we doing things on paper? It's like, you do not know, like, people don't, if you keep an open mind about it, suddenly you'll get the eureka moment. If I'm willing to crumple this up into a ball and throw it in the trash, that's where I want to be. I want my ideas that I have no problem throwing it away because I'm in the ideation phase. I don't have a finished product. If I start coding, I feel like I don't want to change that. Even if I say I'm willing to change it, I really don't. I'll try and shoehorn something to make it work. I want throwaway ideas. I want you to be able to just toss out more than half of them, because that's how you find the right idea eventually. You sort of spray the area and then figure out what works. Okay, so paper prototyping is, by the way, if you don't know what it is, I'm going to make my user interface with little bits of paper that I can paste together and put on top of each other. So it looks like an iPhone, or it looks like a desktop interface, or it looks like whatever the case is. I will then get actual users in to use my fake system, and I will have a person pretending to be the computer moving the pieces of paper around. So when they click, they press, like they go on something on the screen, suddenly a piece of paper slides in, like what you would expect for the actual user interface. So you can simulate what the actual system is and how it interact with it without actually, and it's like you're cutting out pieces of paper and getting glue sticks, and I get like markers and stuff, so that when you can simulate what the actual system looks like and get a feel for how people actually would use the system before you actually try and spend all that really heavyweight time implementing it. Implementation phase will be 20 times longer, and the easiest thing to do is throw away the crappy idea. So we want to throw out the crappy idea first rather than implementing it and finding out it's a crappy idea. It allows you to test things before you do anything. Okay, so here's more paper prototyping, and there's no one way of doing it. That's the point. Here is, let's say, this would be a watch, for example, on the side here, right? Here you go. Okay. I have a little watch, and I can slide this piece of paper back and forth to get different things when I slide back and forth on my watch. And if I slide up and down, I'll get this thing to see, how different instructions for how I can, do. I'm assuming that's an inclined press over there, right? Or maybe I have a bunch of things like this where I move my camera across the way. It's meant to be fun and kind of showing what the actual system looks like, even though no one's going to think you're ready to be finished. No one's going to think, oh, you're almost ready to ship this product. No, it's a piece of paper. No one guesses or gets confused by this. If you want to show your interactivity, you can show a bunch of slices of or images one after the other, showing how you go from one to the other. So here's my to-do list, and maybe if I want to remove ongoing, for example, maybe I slide to, swipe to the slide. So I'll have a little arrow saying swipe, and it says remove it. Or maybe I have a little star, but I put a little bunch of lines around the home button and see what the transition is. Or maybe I have a little dot here where indicating where a click would occur and then what the next step is. It's storyboarding. If you ever looked at movie work, right? It's this, then this, then this. If I click this, then I will get this transition. I can visually represent what my system is going to look like, again, before I actually make it. Because that's easy to do. This takes no time. The actual time is from you implementing this thing, which just eats up your time. So we want to think it all the way through first before getting into it. By the way, I'm trying to get this up and running. So let's see if I have it working. There we go. Someone pointed this out. So what am I looking at? Diagrams.net. Maybe it was one of you guys. I can't remember anymore. There are lots of systems. So this would be another way. This is what's called a wireframe. It is just the basic outline of something, but no one's thinking it's the real thing. Notice the text here. It's not actual text. No one's reading it. It's lorem ipsum, as in it's a bit of Latin text that I grabbed from some random Latin scroll book. I can't even remember where the origin is. It actually makes no sense even in Latin or limited sense. It's just meant to be gibberish, but give you the look of text without actually people reading it. And you can put different tags. No one's there. People know there's going to be a picture here, but you can play around with it. And so you can move this around. Oh, I don't want a picture there. Oh, actually I do, but I'm going to make the background. I'm going to move it over here, maybe. All right. And then here, I'm going to change the text to this. And now, this is not being done on paper, but it's still doing the job, right? I can get a rough approximation for other people to be able to use and look at. There's lots of systems like this. This just happens to be, what? Do we actually have draw.io? That's what it is. Okay, draw.io. Great. Have a look at it. Isn't Adobe XD sort of just a cleaner version of this? I think you have to pay for Adobe XD, don't you? But other than that, yeah, there's a ton of these things. The question is, well, I still want paper first. I'm not playing here because I have to think. I don't want to be thinking about how I do something in the interface. I want to doodle crap out. I want the back of a napkin first. This is stage 2. Stage 2 is, now that I have the back of the napkin, now I can organize it so other people in my group see it. But I want back of a napkin. That's how the Miata was invented. They're like, hey, no one does roadsters anymore. And during a lunch break, they doodled out a roadster. That's what I want. I want a doodle at first, and then you move into the fancier stuff. Great question. All right. So, and then this is how I can show transitions. And I could use something like Adobe XD or something like that if I want to show a series of transitions one after the other. But the initial idea that I want to go on paper, and then I want to go to a higher fidelity later. And so this would be lower fidelity. Then you can go to, something like with Adobe. And then after that, you can do an actual interface with actual code, maybe Tableau to simulate it. And then after that, then you'll actually implement your system. It's a series of higher and higher fidelity prototypes. Because the worst thing you could do is dive into the final product. Same with code, right? You design your code, and you implement it a little bit at a time. What you don't do is go, I'm going to make it up as I type. Sorry, I got something in the back of my throat here, like cat hair. Oh. So here's what we're going to try. So we have a hard deadline for P3. The reason it's a hard deadline is I need to give you feedback fast enough that you can actually do your implementation part. Okay. It was even a harder deadline when we had paper prototypes because then it held up everyone else. but I still want to give ideas quickly. Each group member is going to make 3 distinct designs, not 3 of the same pie chart, 3 completely different designs for what you're trying to do. And then you're going to do effectively a marry, kiss, kill, but without the kiss or the, just the marry, kill, right? You keep one idea, essentially. And then afterwards, you'll merge all those ideas with every member of your group. So you get one final sketch. You're just killing ideas everywhere after, not while you're designing, design crazy, and then kill them all afterwards. Okay. P4 is your final design and will require a presentation, but P3, I want to get some initial ideas to make sure you're not off, going down the wrong path. So here's what we're going to try. And this is going to take up a chunk of time, probably the rest of the lecture time. So let's try this though. So for 5 minutes, I want you to write down individually a data set that describes something that you are passionate about. Okay. So something in your spare time. Doesn't matter what it is. It doesn't have to be a large data set. Just, a reasonably sized data set, like 8, 10 numbers, something like that. Then I'm not sure if I'm going to auto pair up or I'm just going to I think I'm going to make a bunch of groups that are pairwise in size. Okay, so you can group together or find some random group that you were not part of and then join. I think we can do that. So you can just randomly join groups yourself. Or I can do it automatically because you should be able to talk to almost anybody about this. One person will be the stakeholder. You are just describing the data set that you're going to be using. If you have a file, you can send them the file, but you're just describing the data set. You do not look at the other person's visualization. You're going to use their data set. You can ask them questions about the domain. You're not going to ask them, do you want a bar chart? No. You're not going to ask them, hey, what color scheme should we be using? No. You're just going to figure out what the task is. And your job is to do what we're doing for P3, which is you're going to make a visualization based off of what you know about the task. So take the data from P2, make it to P3. We're going to do that here in a little microcosm version of it. Doodle something up, piece of paper, right? Take a photo of it. Then you're going to switch and do the same thing again. I don't think we have time for, maybe we may not have the time for the reverse, but at least do one of these and we'll show each other's designs and the stakeholder can explain or discuss strengths and weaknesses of the design. That's the key part. I want to make sure you don't forget that part. So when they do something and you go, I don't like it because of this, this, and this, that's where the learning happens. Okay. So I want to make sure the 10-minute design part, great. I want to make sure you do the strength and weaknesses part. That's not taking the other person to task or making fun of their ideas or anything like that. All designs are wrong. All designs have things to improve. You have to be nice about it because it's not you, it's the design that's being critiqued. It should always be the design, not the person. Okay. I'm going to see if I can get groups, but for the next 5 minutes or so, come up with a data set and then you can join a group. Okay. I'm going to put a pause to my recording. I'm going to stop sharing it. No, I can't stop sharing, can I?